Alright, we are going to see some properties of parallelogram from the chapter. Let's start with theorem 8.1. It says a diagonal of a parallelogram divides it into two congruent triangles. So here I have a parallelogram ABCD. First, let us join a diagonal. So here AC is a diagonal. On drawing the diagonal, the parallelogram is divided into two triangles, that is triangle ABC and CDA. According to this theorem, on drawing the diagonal, it is given that triangle ABC is congruent to triangle CDA. That is what this theorem says. On the other hand, if you join the diagonal BD, once again we form two triangles, that is triangle DAB and triangle BCD. Once again, these two triangles will also be congruent to each other. That is what theorem 8.1 says. Now let's move on theorem 8.2. Theorem 8.2. Opposite sides of a parallelogram are equal. So here I have parallelogram ABCD once again. We have AB, BC, CD and AD are opposite. They are the sides of a parallelogram. AB and CD are the opposite sides. That means AB is equal to or congruent to CD, which are opposite to each other. BC and DA are equal to each other. That is what theorem 8.2 says. Moving on, let's go to theorem 8.3. A quadrilateral is a parallelogram if its opposite sides are equal. So from theorem 8.3 it says, in any quadrilateral, if the opposite sides are equal, in any quadrilateral, if the opposite sides are equal, that means if AB equal to CD and then BC equal to DA, BC equal to DA, then we can say that ABCD is not a simple quadrilateral, but it is a parallelogram. That is what theorem 8.3 says. Now theorem 8.4. Opposite angles of a parallelogram are equal. As we know, in a parallelogram we have four angles, that is A, B, C and D. Here the opposite angles are, to angle A the opposite is C. So angle A is equal to angle C and then angle B is equal to angle D. That is what theorem 8.4 says. Opposite angles are equal to each other. Now theorem 8.5, it says a quadrilateral is a parallelogram if its opposite angles are equal. Now it talks about quadrilateral. Here, if ABCD is a quadrilateral, a simple quadrilateral, and if we have that angle A equal to angle C, that means angle A equal to angle C, and then angle B equal to angle D, angle B equal to angle D, then we can say that ABCD is not only a quadrilateral, but ABCD is a parallelogram. Once again, that is from theorem 8.5. Moving on to theorem 8.6, it says a quadrilateral is a parallelogram if it has a pair of parallel and equal sides. Now in any quadrilateral, here ABCD, if AB is equal to CD, opposite sides, and if AB is parallel to CD, then ABCD is a quadrilateral, not only quadrilateral but a parallelogram. That means if AB is equal to CD, and again if the same AB is parallel to CD, then we can say that ABCD is not only a quadrilateral but is a parallelogram. Once again, that is what theorem 8.6 says. Now theorem 8.7. The diagonals of a parallelogram bisect each other. So here I have a parallelogram ABCD. where AC and BD are the two diagonals intersecting each other at O. According to this theorem, diagonals bisect each other. That means they divide themselves into half. That means AC is divided into half by BD. This is the point of division. That means AO is equal to OC. That means AO equal to OC, or we can say that AO is equal to half of AC. Similarly, BD also is bisected. That means BO is equal to OD, or we can say that BO is equal to half of BD. That means in any parallelogram, diagonals always bisect each other. They divide themselves into halves. Now theorem 8.8. A quadrilateral is a parallelogram if its diagonals bisect each other. So in any quadrilateral, if it is given that if we have that diagonals bisect each other, that means if AO equal to OC and BO equal to OD, that means diagonal bisect each other, then we can say that this ABCD is not only a quadrilateral, but it's a special quadrilateral, that is a parallelogram, only if diagonal bisect each other according to this theorem.